Happening here, this is a talk in 3 parts, do's and don'ts of data viz in general, do's and don'ts specifically for web viz, and resources here at Stanford. So why should we visualize data? And the short answer is because it's the best way for us to get complicated information into our brains. And we get comprehension, we can see patterns, trends, outliers, all manner of things that would be hidden from us if they were presented any other way than visually. So I'm not the first person to say this. There's a guy called Anscombe. He was a, oops, what's that? Oh gosh, sorry, I touched something. He was a, sorry guys, a statistician, and he came up with this table to prove the limits of statistical analysis and the power of visualization. So just looking at this table here, you might not really, nothing kind of might jump out at you. You might see the pattern. Well, first of all, what is it? It's actually four tables with X and Y values. So in the fourth table, you might see in the X column that there's like a pattern of 8s. And you might actually notice that the X values on the first 3 tables are all the same, but you might not notice that. And what does that mean anyway? Does that mean they're all the same? Are they different? It's completely hidden to us when we just look at it. So Anscombe said, okay, let's do some statistics. So they ran some statistical tests, the means and the variance of X and Y correlation, and then they found extraordinarily all of these results are exactly the same for every data set to a few decimal points. The linear regression line formula is the same. So what is going on here? You would be okay at thinking, oh, they must be the same. This is like obvious, they're the same. But hold on a minute, let's graph it. So when we graph it, lo and behold, we see so many things that were hidden to us. You know, this linear relationship, the curving, this thing, something else going on here. It's really quite extraordinary and dramatic. So, okay, that's convinced me. Let's do it. How do you data visualize? As we've proven here, it's the best way. So there are many models. This one comes from the R programming language, and it's a fairly representative model, I think. The idea is that you get your data in here on the right. You import your data, you tidy it, and then there's this kind of cyclical process here where you're modeling, transforming, visualizing, and you're going around and iterating, and then you're ready to communicate your data. And it is a fairly fairly good representation, I think. You know, it might not show you that, like, or you might get, it's kind of interdisciplinary that you have, you know, data science, computer science, design, statistics, obviously, and stuff like that. But I do think that there's one change that could be made to this graph that would better represent the actual process. And I'm sure anyone who's ever done it will agree with me that it's better represented like this. So that's first joke, guys. This is to show you that 80% of the work that you do on a data visualization is going to be cleaning your data. And it should rightly be so because, you know, this is the most important part. This is what you want to get across. And if you don't have clean data and good data, don't even bother. So what is some data do's? Clean data, I've mentioned before. So what is it to be clean? Well, that you know, no incomplete records, no duplicates, no corrupted records, no outliers, if that's important, anonymize it, etc., etc. That it's complete. Don't cherry pick your results to suit yourself. Really show what, you know, take all the data that was recorded, warts and all. And representative. And by that, I mean that it is, you're getting the data that is going to give you the most insight into the problem. So for example, if your question is, I wonder if there's a lot of flu going around at the moment, then you're best to get your data from Google search words of flu symptoms, rather than the CDC, which would not have that information for very many years to come. Okay, so that's a data viz. That's how you do it. Let's take a look at one. This is a very old one, but a good one. And it's kind of a modern update, but it's the same graph. So what's good about this, you ask? Well, it's got a title, okay? That is another do. Do put a title in. That, if you have a point to make, and you should have a point to make, put it in your title. Unemployment rises for the third year in a row. Strong link between being broke and being sad. You know, whatever it is, put it there and don't be afraid to punch it up like he has with bolding, etc., etc. What else is good about it? Well, look at the amount of data that he is displaying here, okay? So, another thing about the thing. The reason, like the chances are, if I asked you, what is this graph about? You would say back to me, oh, I think it's about, you know, the successive losses of men. That's just to reinforce what is really important is going to be communicated. But anyway, back to the data. So he is showing lots of things. He's showing numbers of men, both in kind of, these are numbers here, and also encoded in the width of the lines. He's showing distance, so you can then get a sense of how much they marched and how far they marched. He's showing geographical features in the form of names of towns and rivers. And you can really see here, like the drop off, like probably crossing the river. He's showing temperature. Look how cold it got. Here on the 30th of December, minus 38 degrees. Like, that really gives it a sense of how cold it was. And he's annotated it over here on the left, well, on the right, the left for you. It says the Cossacks passed the frozen Neyman at a gallop. I don't know what that refers to, but it's very vivid. And he obviously wanted to draw attention to it. He also never mentions Napoleon. He gets a kind of a dig in, who, you know, was really obviously the cause of all this death. But another thing that's really good about this graph is that he's chosen exactly the right chart to display the data. This is a Sankey graph. And it's to show the movement. It's very good at showing movement or flow of like goods, or in this case, men. And it's also very good at showing a process from start to finish. So he's really picked the right chart. So because this is a beginner's talk, oh shoot, I forgot to start my timer. Does anybody have how long we've been on? Anyway, okay, I'll just carry on. Okay, so I am going to do a little introduction to graphs. This is not anyway comprehensive. It's just kind of, these are graphs that I use and I have something, do's and don'ts to say. And a lot of the do's and don'ts that I'm going to point out here apply to lots of other graphs. So we'll start off with the pie graph. It's lovely and colorful. This is the much maligned pie. You know, this field is so opinionated. People, you know, don't really say you do you. And the opinion about pie is that you don't have a pie except for dessert, that you don't have them. And the reason is that it's very hard for our brains to gauge, you know, if you had a question, which is the biggest here? Is it yellow or green? You don't know, you can't tell. We can't tell as much, we're much better at solving that kind of thing. So people saying never ever use them, there's always a better graph. But I kind of disagree, there's a bit of disagreement. And I think, yes, do use it for binary data. This is a fantastic graph. You got your values right there on the piece. You got the percentage, and it's very, very clear what's going on here. Do place it in a sidebar because you have a lot of white space. You want to minimize that, and don't explode the slices. It's stupid. Don't distort the data. That's a very, very important part for rule for every graph. Do not 3D it or do anything fancy. But it's particularly egregious when you put it, when you 3D a chart like this. You can see you completely lose. Like, this looks the same now, or this even looks bigger. You kind of belie your eyes. And it just places a huge cognitive load on the reader and or the viewer, and you don't get the benefit of our inbuilt stuff. Far better to answer the question, which is the biggest, is a bar chart. This is going to be your workhorse. We're so good at judging, you know, length. That's just really one of the things we're super good at. You want to sort it. This one is sorted in month order. So it's easy for me to kind of go along if I'm looking to find something. Oh, there's August. You can sort them in ascending order. This is kind of a story of growth. Something's going on if you want to show growth. But mostly we show it in descending order. And that's because we're kind of obsessed with what's big. And it's easy then to read it right up against the axis. You can tell the value. Do use horizontal text. Don't do this. You see this. Like, you could just abbreviate it, or better, use a bar chart, which, you know, allows you to have the thing, or a horizontal bar chart, I mean, which allows you to have the variables as long as you need them. But, you know, and on mobiles and stuff, you can have infinite scroll, you know, but don't overdo it. Don't have 50 things where you're going to lose the effectiveness. and something like that, you might want to rank them the top 10, top 20, something like that. Or you might want to use a lollipop chart, which is something I've been seeing a lot, and I like it. And it's nice and clean, and it kind of puts the focus here on the value rather than anything else. So it's also if you have a lot of values. Again, you want to sort that. Okay, here's another do. Do start your axis at 0. So Fox News is notorious for misrepresenting charts and things. And looking at this, you know, it's very dramatic. Oh my God, between now and January 1st, it's just going to be a disaster. But then if you look closer, you see that they start the axis at 34. So like all this bottom half of the chart here that starts from 0 to 34 is missing. And really, it's much better represented like this, starting with the 0 axis. Okay, so that is a must do for bar charts, but only for bar charts. So you also see stacked bar charts, and these are good for comparing parts of the whole, like, you know, that you can see in March, I had a lot of green or something, but it's not very good at saying which did I use green more in, like, you know, November or April. So far better to use a line chart, which again is another stable, or another workhorse in your stable, your go-to guy for depicting metric over time. Everybody knows how to read it, and it's very clear what's going on. Some do's, do directly label your data. Here you have a kind of a legend where you put a cognitive load on the reader, and you really don't want to do that. You just put, like, you know, put what it is next to it. In fact, you could even push it further and put this green, red, and blue to really push the connection. So you can also have step line charts. That's not a step line chart, that's a normal line chart, but showing postal cost over time. And this would be better represented as a step line chart because you have such granular data, like this once a year thing. It implies that throughout the year it was going up, you know, it was like 34 halfway through the year or something. So you want to use that and represent it something like that, where you can clearly see, you know, it didn't go up all here. And it really highlights kind of the dramatic rise of postage here, where you didn't kind of get it when you interpolate. Here's a do and a don't. I was going to have a drinking game that we would have a drink when we'd have a do and a don't, but here's a do and a don't. Do, don't cut the y-axis, only for this particular graph, a line graph we're talking about here. So on the left, we see this was tweeted out by the National Review to show what is all the fuss about global warming. It has not gone up since, you know, 1880. And of course there is war over this because it is not really representative of what's important. So you do want to cut the y-axis or truncate it when it's things, small movements that matter. So things like the stock exchange are going to cut the axis and just show you what it went up in. And of course temperature is very important. These small changes are catastrophic, really, kind of cut, you know. So you do cut it when it's important, when you're showing small movements, and you don't when it's not important and it doesn't affect the graph. Do limit the number of lines. About 5 is about as much as we can process, and now you're starting to obscure the data. Better, in that case, when you want to kind of compare things, to use small multiples, and this is a great one. Showing an awful lot of data. It's like 45 countries over 20 years, so that's an enormous amount of data. But you can really clearly see the outliers. They've sorted it for us. So South Korea is something that's going on there. They're drinking a lot, and obviously they're not drinking too much down here. But you can see trends that Russia and Brazil went down, the Philippines went up, and then something happened right here that made them double their drinking. So that would be something you'd like to look at. That's a good one. Here's another good one. This is showing the rise of political parties getting elected in Europe. And this is another good one, as I say. This is a stacked bar chart. Small multiples. But the one thing I want to say is you keep your axis the same. Do keep your axis the same. These axes are not exactly the same, but it's okay because these are elections. So it's okay. But normally if you didn't have your axis, you would explain it. Oh, I'm just not going to do that. I don't have time. So then we have pictograms. I really like pictograms because what are they? They are where you kind of encode what you're talking about. You put an icon. Okay, so here, just a complete silly thing is like when KT's shoes fell off, and you can clearly see that like nobody stepped on his shoe 2018, or his left shoe rather. You know, you just kind of get a sense of fun, and they're really good for small data sets. If you've got too much going on, it's really ineffective, and they're also very good. Oh, just use them for whole numbers. Don't like cut off, don't cut off part of the shoe to denote something. Just use whole numbers. There's a really effective one from Germany, just trying to get people to take the bus. So I think, it really just says a lot there. So it can be really effective. Okay, so that's what I'm going to do on charts. And by no means is that the whole of charts or every chart you're going to need or under what circumstances. So don't worry, I am now going to teach you how to fish, or rather I will give you a fishing rod. So here are some resources from the web, and this is one from the Financial Times. And so you say you want it, and it's kind of a step, it's just a little help, say you wanted to show deviation. Well, then they say, well, what is that to show? Okay, you could show that for, trade surplus deficit. And these charts are good. And then they give you a little bit of information about each chart. So, you could say, okay, part to whole, here's our pie. They say, be careful with the pie and the donut, whatever. So there's a lot of information that you can get there. And that's a good one. But this is my favorite for this kind of thing. This is a great resource. It's called From Data to Viz, okay? And it's just a wealth of rich information. So you can, so first of all, they ask you what data you have. There's a decision tree, you can go down it. What kind of data? Oh, I have here. And then you've got all these kind of helpful pop-ups. I could say I want to know about a Venn diagram. They give you this, they tell you the mistakes, and they actually will send you to examples of the code. They also have some of these have dedicated pages where they talk about the mistake you can make, so that's an excellent resource for that. So then you can also go further down and see they have some data sets that they've kind of played around with. So if you wanted to show, so they have a data set here and they kind of just will go through what they did with it. How they put it into a bubble plot, blah, blah, blah. And they do that for loads of different data sets. And you can see the results for yourself and why they chose them, why they might be good or bad. And then they have another section where it's like, okay, this is how to mess it up, which is great. And then there's a bit of eye candy for us, they're lovely Frenchmen. Okay, so then that's that. Okay, moving on. Oh, just a couple of things about fonts. Legibility is your goal here. You want to make it clear, don't have anything fancy. I said already about horizontal strength, and use font size and strength to establish hierarchy. By that I mean, put your title in a H1, put your subtitle in H2, use that already existing, well, on a web page, hierarchy framework. That is going to help you later on. So test your viz, show it around, take out the title, see if people still get it. Change up the colors. I haven't talked anything about colors, but they're important. Have testers representative of your audience. If you're trying to get people to get a joke or something, then you want people, young people. And, always try and have some testers with low vision. Okay, so that's part one. And we're going to move on to part two, data viz on the web and do's and don'ts. So how do you put your viz on the web? So you're going to have either an image, a static image, you make your viz somewhere in some form, and then you make an image and you link to that in an image tag. Or you draw as viz using software. This is just to set some context. So what's different? Well, your data is different. Your source of data, you're probably either going to be hosting it on your own server or getting it from an API. So your data is, potentially up to the minute. That's one thing that could be different as opposed to static source. You have meta tags, which mean your document is now searchable. So if it's something you want out there, you want to be using those meta tags to improve your search hits. But the best thing about the web is that it has potential for user engagement. And I'll go into that a bit more. So I am going to go over do's and don'ts kind of in these 4 categories. And you can read, so I won't bother. But I'm going to start with accessibility because it's very important here at Stanford as well, it should be. So to be accessible, web content must be all of these things. And I can immediately, just looking at these, think, uh-oh, we're in trouble. Perceivable, obviously if I have a visual and somebody has no vision, cannot see it, it's not. Operable, if I have some kind of interface that enables you to search and filter the data, then somebody with a motor disease might not be able to operate it. Understandable. If I'm using red, green, I haven't talked about color blindness, but if I'm encoding something with a red, green, a person with color blindness is not going to be able to understand it. And robust, is it going to be okay across different browsers, across screen readers, or across, I think phones should be included, like, you know, older versions of phones. But anyway, that's not fair. So how do we do this? How do we do it? And you know, we follow the WCAG guidelines here at Stanford. And the very, very first one says, if you have non-text context, you must have a text alternative. Okay, so it's absolutely key. And the good news about that is if you have been following best practices, so if you have a title that's very clear about what point you're making, or if you have used the hierarchy of H1 for your font and, you know, H2 for sub things, then you're kind of already halfway there because you have already put systems in place for people who need to see text. But let's go, you know, do a bit more. There's more we can do. So you want to use alt text when you have an image. This is the first type I talked about. You attach an alt attribute, is it an attribute or whatever, to the image tag. So what do you want to do with your alt text? You can have it as long as you like. There's no limit. You can have it unlimited. But you really want to be concise and get to the point. And that is because screen readers, you know the way people can listen at like double the speed and they're kind of going along like that and they can hear very quickly. Well, you cannot play alt text at speed, or you cannot skip it. So you're basically holding the person hostage who's using a screen reader, forcing them to listen to what you've got in the alt text. So be concise and get to the point. You want to say, don't say it's an image because the screen reader says it's an image. So you're saying it's an image, it's an image. Do link to a machine readable file. You know, this is, I don't know if this is all that useful, but it's there. Okay, I don't know what people are going to do, like read the raw data, but they say do this. So that might be just kind of lip service. And you want to end with a full stop because that kind of gives a pause and a semantic kind of cue that it's over. Unfortunately, in the second type, you cannot use alt. Well, you can, but it's not, you know, good at HTML if you use an alt. So you have to use ARIA, and ARIA is this kind of a shim between native HTML, like when it falls down, and assistive technology. So in that case, you need to put that it's an image. You give it a role. You say it's an image, and it's the screen reader is going to treat it just like an image. And then you put your ARIA label in there. You would have your text depicting, you know, bar chart, whatever. Okay. Okay, so, but just, you know, I've been thinking about this for a long time, and I think those kind of things, they obey the spirit of the law, or the letter of the law, but not the spirit. I mean, I don't feel that this is really equivalent. And, you know, I don't have an answer. I kind of been thinking about maybe various ways that you could, you know, maybe you could link to an audio file where the person is explaining it, but that might be a bit too directive if you want them to kind of get their own conclusions. Or my latest is that you could maybe link to a 3D printable model of what you're doing. Anyway, you know, there's just, I think it needs to be pushed a bit more. This is a bit too easy, but do the least. This is the least you can do, so do the least. Okay, do research color. I talked a little. So this is blue and green, very obvious to us who don't have color blindness, but this is how it looks to someone who's colorblind. But, you know, there are color-safe colors, and you can just search the web. There's so many resources out there. But this teal here kind of still promotes the, you know, our cognitive green good, red bad kind of message we might want. But it's much more differentiated for people who have color blindness. You can use white space. Imagine that you had color blindness and couldn't see. You would not be able to differentiate between these on the left, but yes, with the right. But then that kind of, you know, interferes. But anyway, you know, use your own. Okay. Do use interaction acceleration techniques. So what is that? So what that means is, well, I'll demonstrate what that means. So here's an interactive visualization of flights from airports, okay? So I'm going along, and you know, this is a great one. There's so many users, this is such a good thing. Decide I want to see it, okay? But now imagine that I can't control my hands, or I have Parkinson's or something. Like actually mousing onto that small dot is very difficult. But I don't know if you noticed that as soon as I came here, it now shows that. it assumes that's where I want to go. And what's happening there is there's another visualization underneath that is charting like the nearest points to things, and it's using that. So anytime I mouse in here to any one of these points, it's going to go to the nearest airport. So things like that, there's lots of stuff like that out there. You can make your mouse a bubble so that it's getting more than just the point. So, you know, use techniques like that. Okay. Okay, so also you must test for accessibility and test with the screen reader, obviously. Again, I mentioned the colorblind person before or something. Check that you can respond, if you have interactivity, see if it responds to voice commands, you know, drop down, make that drop down, select temperature or something, you know, for somebody who can't move or has motor difficulties. Run in high contrast mode. You can download like plugins for your browser, yeah, like Chrome or something, that put your thing into high contrast mode, which people with low vision find helpful. So you want to test it, you want to download that, and use emulators. There's a lot of really great stuff out on the web, you know, about how does this look to someone who's colorblind, or, you know, who can't see, you know, and stuff like that. So that is something that you want to use, and it's a lot of fun. Okay, here's another do make your viz responsive. So when we talk about, you know, the web, we are talking about people, we have no control, really, to the large part, over how they're accessing it. So, okay, I left out a slide because I didn't have time, but one of the things you should do before you make a viz is you should ask yourself some questions. And one of the questions is, who is going to look at this? Who is my audience? That's probably, you know, your number one question. And that's a kind of a two-layered thing. It's one, are they going to be able to understand my charts? Are they familiar with this subject? You know, that kind of a level. And also your question is, what kind of a user are they? What are they device are they accessing your stuff on? So theoretically, you know, we can go all the way down from a watch, you know, right up to these massive great screens. So you want to design just one viz that's going to be useful for all of these. You don't want to be designing multiple viz, okay? So what do? Here's another don't. Take a drink. Okay, so the web standard is mobile first, okay? If you're designing something for the web, go mobile first. But that might not apply in this case. How do you decide whether you do mobile first or desktop first? You use your analytics. If you're not using analytics already, start using analytics. This is from StatCounter, you know, they kind of survey millions. So if I was going to do one that for the whole wide world, the first thing I would do is see what are people using. So this is what StatCounter says, and you can tell. By the way, I don't really like the gradient on their bar chart. I just, you know, just saying. Well, you can see that the, you know, the mobile and the tablet are much bigger. So that would be the audience. I would start off that my audience is going to be mobile. Okay, so do use Flexbox. That's all you have to do to make your stuff mobile is put it in the grid, and you know they'll take care of all that. And Flexbox is very hard to learn, but just do it, bite the bullet, and it'll make your life easier. Do use interactivity. Okay, so this is another, like, do use interactivity, if at all possible. The benefits are just massive. They, you know, it just can delight. I mean, I hate that word, delight the user, but you know, it can be really, really engaging. One of IBM's design principles is make users feel smart, and you can feel really smart and feel like you get a handle on difficult data if you have interactivity. You can, you know, display so many dimensions of your data. You can hide the data, or you know, change your axes up. I mean, you really have so many techniques at your use. So let's take a look at one. Actually, okay, let's just take a look at this one. This is an interesting one. So this doesn't look very attractive, does it? This is a parallel coordinates plot, and it's good for showing dimensions, different dimensions of data. And this is a very complicated data set. It's about cars with 7 dimensions. You can see them across the top there, and it's like from years to year, okay? So I'm like, oh my God, look at this stuff. What the hell? But, you know, just say I wanted to look at heavy cars for some reason. So I can now select just the heavy cars. And immediately it becomes obvious, the patterns in others. They're all 8 cylinders for one. They all have lousy gas mileage, high displacement, and they all can kind of get to from 0 to 60 very quickly. So, you know, I can reset it, and then I can say, I can look along 2 dimensions. Let's just say, okay, I want a car that has only 35 miles an hour. Well, even just that, I can see, oh, look, they're all new cars. So I can now make the assumption something changed the way we make cars, you know, around 76, 77 kind of thing. I can now say, okay, but I want them, you know, I want them to be kind of powerful. So, you know, I'm now able to kind of look along and play around and really get a sense of what is going on with this very complicated data set. Okay, do make it obvious. So do build on existing mental models and design patterns of interaction. What does that mean? Well, that means that when you portray a map, people are going to expect that they can zoom on it, they can pinch on it, they can put a marker on it, and let them do that. Don't have some fancy thing where they don't know what they're doing. Really use, you know, the design pattern of interactivity is that you get an overview and then you drill down, so you expect, you know, that you'll be able to click and that will drill down. You know, all of these things that you, if you hover over something or you tap it, it's going to give you some tooltip or something. So do use those because they are so effective. So now I'm going to show you some really cool interactions. So this is called the Galaxy. Oops, there you go. Sorry, mouse is interfering with it. So this is called the Galaxy of Covers, and it is from the top 50 covered songs. Okay, so these are the names of songs, and in the middle is the original artist, and then all around them are these kind of satellites. And there's some obvious encoding going on, but there's just some really nice things happening here. The way the animation allows you to see things that might otherwise be obscured. It's an awful lot of data, but it's only kind of going to go out for, you know, one of them. If you hover over it, it stops and you can see, oh, that's always on my mind. And now here's another interactivity. I'm going to click on that and I'm going to want to see what happens. And then there's this lovely animation where your eye follows down the data, you know, and we can see this is the one that we had. I know that because I looked and I saw it. And then they have all of this really cool encoding. Like I can see immediately down here, this yellow one is kind of different. What's different about it? Oh, it's a hip hop version. You know, they have some encoding. Like they have really lovely explanations here of their symbols. And, you know, you can really get a sense of what is going on. And it's a tremendous amount of data that is being displayed in a really efficient way, and also, of course, a beautiful way. So, you know, you can see immediately which ones are covered more than others. And like I say, a lot of data and just a really fun experience. What else have I got? Sorry. Oops, guys. Oops, sorry, okay, let's go back to PowerPoint. Okay, so, sorry. Indulge me for a minute. It's hiding my thing. Oops, where's my window? There it is. Sorry, guys. Okay, so here's another one that I really love. And this is called, let me just refresh it here. So this is just amazing to me. This is a lovely one from a woman called Zan Armstrong. And what we're seeing here is data for the last 30 years, okay? Everyday average temperature, okay? And there's not only that, but here she's hidden a lot of the things and allowing the user to select. So if I wanted to see, you know, percent cloudy, I get another one. I have lovely encoding here along the side. You know, I can just kind of see, oh, this was March. Oh, and this is lovely. Look at this lovely tooltip here. So what it is, she's using kind of the clock, you know, the circular thing of a clock. So this is from midnight. This is a full day's data. So, you know, the way you use it is you go down around here and you see, okay, I can clearly see it was kind of really cloudy at 5 p.m. in, you know, what's that, October or November, you know. And then she's got lovely kind of like instructions here. Click to choose Fargo. So let's see Fargo. What's that look like? So, okay, that's kind of cloudy, so that's not very dramatic, but let's do temperature. So look at Fargo, okay? How cold it gets. Right in there at like 10 degrees in the winter at 4 a.m. Let's see Chicago, Minneapolis, it's probably even colder. You know, you really kind of get a sense. Let's see San Francisco. See how cold it gets here. Oh my God, it's freezing at 48. So you can see there's like not much variance immediately in temperature between something like, you know, one of the East Coast places. And, you know, you can also vary it by white lines. I don't know that that's very effective, but you can do it. So this is just something you could really have hours of fun with. And it's extremely informative. I'm not even interested in the weather. And I want to stay here for a long time. So that's a kind of a good one. Moving on, I'm going to talk about animation best practices. So this is another lovely visualization. It's called A Day in the Life of Americans. And it's just, you know, you can see it's how we spend our time. So there's a lot of animation actually happening here. So the clock is animating and these people are animating, and you can vary the speed of the animation. So you can see it slower or medium. And here's another animation. That text came in. That is something to do with the time of day. And so that everyone's having coffee, they're kind of annotating it, and they're using that to show you different things. So that comes in and out, and then it flies out when it's no longer relevant. So in a really nice way, again, helping you to kind of visualize it. So what you want to do is, the first question you ask yourself about animation is, do I need it? Okay, so obviously, yes, you need it in this situation. And I heard kind of an analogy about, like, animation is like chili sauce. That a little goes a long way, and can really spice things up, but if you have too much, it's all people remember. Okay, and I know there's people out there who can like chili sauce, and this is just for the normies, okay? That think about it that way. It's a bit corny, but yeah, be careful. So I'll go back now to the slide. And so you ask, is this needed? Do use it sparingly, okay? We've already mentioned, especially on mobile. It's a huge, you know, mobile phones don't have GPUs. Well, they do, but they're not as powerful. They don't have the bandwidth to take massive amounts of data. They can't process, you know, stuff. So be careful. You should even disable it, or if you don't disable it, if in doubt, disable it. And if you don't disable it, use CSS for transitions, because it's a lot more performant than iterating through using properties using JavaScript or an API. So do test for the web. What do you want to test? Your different devices, your different browsers. You're going to test and link every line of code. That's what you're supposed to do if you're writing code. So presumably you'll have some code. And do some data throttling for mobile. You know, play around with speeds, et cetera, really try to get your user experience. Because animation is awful. If it's janky, it really takes you out. You know, it's a total waste of time and process. Okay, so my third part of the talk is resources at Stanford. And first resource at Stanford is you can audit classes here with the permission of your supervisor and the instructor. So you just send off you can go to explore courses, you can type in data visualization in the catalog, and there's 43 results. Now they're not obviously all offered at the same time, but there's a good one. I've taken it. It's, where is it, sorry. Well, it's on data visualization. Oh, it's right here in front of me. It's called Data Visualization, Techniques and Algorithms for Creating Effective Visualizations Based on Principles from Graphic Design, Visual Art, Perceptual Psychology, and Cognitive Science. Topics: graphical perception, data and image models, visual encoding, blah, blah, blah. Anyway, you get it. It's very in-depth and useful. And this is just one of the 43. So that's great. The library is the best thing about working at Stanford. It is such a fantastic, fantastic resource for anything, but for data viz. So go to the library webpage and type in data viz. And you will get literally hundreds of thousands of hits that are available, some right there online in the form of videos, articles, books, you name it. It's there and it's right up to date and you can use it for free. Another service offered by the library are these things called pragmatic workshops. Does anybody know of these? Anybody taken any of them? So these are between 2 and 4 hour workshops that are put on by the CIDR, the CIDR group there. And they kind of aim that you will just kind of get a taste and you'll come away with a skill in a couple of hours. So it's kind of a little dip. But here are some ones they've offered recently. Data visualization with Tableau, basics of data visualization, data modeling from research materials to data, preparing your data and code, blah, blah. Anyway, you get it. There's a lot of stuff out there. It's free to everybody who wants to attend from Stanford. They also, and this is saving the best to last, offer consulting to people who walk in and want expertise on data visualizations. So they will help you source your data. They will see if your data is in compliance with any copyright or stuff like that. They will help you with algorithms. It's a fantastic resource. It's every day between 2 and 5, Monday through Friday, at the Vernon. I forget, but I'll put in the notes. It's just look it up. Anyway, sorry, I don't have the exact thing. But the best thing is community. These are people I just randomly picked from the web to represent your colleagues who are extremely helpful and knowledgeable and really a great resource. There's, there's communities of practice, there's lunch groups, there's a happy hour. People really want to connect and share and learn, so do it. So a couple of minutes, I want to end up with something fun called Visualizing Out of the Box. And it's just examples of visualizations that are not on the web or they're not on print, but they're kind of fun and it's maybe a way that you might like to do something. So this first one, this is a necklace depicting air quality in Sheffield, it's a town in northern England. And you can see they've encoded on a few levels of color, obviously, the size and the spikiness of the beads. And you can see here, like this is kind of, like this was when fireworks went off. But this one here obviously stands out. This is the evening of the 5th of November. Does anyone know what happens in England on the 5th of November, what it's called? Guy Fawkes Night, also known as Bonfire Night, where they light bonfires all over the place and burn things. So no surprise there, the air quality is dreadful. This is another cool one. It's a bracelet depicting the annual average kind of temperature every day for Canberra, Australia, and these holes are representing rainfall, so encoding on another couple of things. This is one of my favorites, you might have seen it. This was made by a woman who takes the train to and from work every day, and she knits a robe for each leg of her journey, depicting the delays. So pink for 5 minutes, or grey for 5 minutes, pink for up to half an hour, and red for delays in both directions for more than half an hour. So you can see it starts off okay, but then she has like a summer of hell. This recently sold for like €8,500, and it's going to a charity that assists passengers in stations. This is one I found on Twitter just this week. This is made by a woman. She's a city councillor in Montreal, and she knits during the council meetings to calm herself down. It's stressful. So she decided to knit when men spoke and when women spoke. And there's 31 women and 34 men. So this, guess which one is the men, guys? It's the red. So there's a very powerful story to be told there about, sharing and who's talking. And again, like I say, that's just this week. This is fun. I think we should do this at Stanford for sure. This is called physical bar charts. And the idea is that you have all these bar charts, and you can see here there's like a little thing. They're full of buttons with colors that you put on your clothes. So the idea is that you ask a question, and then you say, you have an answer, like, I helped someone, I did nothing, I consumed less, I invested in my place, I spoke up. So that would all correspond to that. And you would take one, and this would form a kind of an inverse bar chart. So unfortunately, here it looks like most people did nothing. But, you know, maybe it's early days yet. And I just think that would be very cool. It's a way of getting community, see who's alike, sparking conversation, etc. And finally, this is called Dado, okay? And this is actually, this woman got an award for this. And it's where people are now, it's kind of a movement where people are visualizing in Play-Doh. So this is her idea of your expenses if you get a doll. And then here's another one she did. This is very cool. She's encoding on, this is how you cook a turkey. So this is kind of a pictogram. And she's got the picture of the bird. And then this kind of like means you put the oven on at 350 and then you lower it to 200. So it's encoding along time, along color, and along temperature. So it's very, I think this is great for kids. The UN has said that data visualization is one of the skills that we're going to need for a sustainable future. So get kids into it, get them chart literate. This is a fun way, not just for kids, for us too. We're done. Remember Saul Lay? I forgot all about him, remember? Anyway, thank you guys for listening. Okay.